Hello guys, let's try to understand interactive problems. So what is an interactive problem? It is a type of a problem where your solution should interact with a greater problem. Let me write it. A problem where your solution interacts with a greater problem. Greater, right? Basically it's a problem judge. So what are these terms? Right? We'll see it in more detail also, right? Right now you can understand it in this way, that you are sending some output, you are trying to print something, you're printing something on the screen, right? And there is another code that is written on the other side of the compiler, right? So what is that code doing? That code is taking this, the thing that you are printing, that is taking it as an input, right? And then it is giving you the output, right? So basically there are some set of rules, right? It will be already defined in the question, the queries. We have these types of queries, you can ask these types of queries, and whenever you are trying to ask something you need to print it in a way, right? And when you are trying to print it on the screen, the other code, the grader code, the judge code, the compiler code, it is returning you the output of that particular input that you are giving to it. And that output is also defined in the question. We'll do a question from code forces, and we'll do 2 3 questions, right? So right now what is happening, that you are trying to query something from the compiler, right? The judge, the other code, the code on the other side. How are you trying to query it? By printing some set, by printing something, right? And that something is already defined in the question. Every question has different types of queries, right? Some will ask you to print strings, some will ask you to print integers. We'll see that, right? So right now understand this thing, that you are trying to query something from the other code, the judge code, and that is giving you some output. So what are you doing of these output? This output is basically input for you, right? Because that is giving something, and then what you will do is you will see in it, that means you'll take it as an input, right? Now I have taken some information as an input according to my query, right? Okay guys, this input is for the this code, and this is actually my output. I'm printing something, the other code is taking it as an input, then the other code is giving me an output, and I'm taking it as an input, right? It's like a query. So when I'm taking something as an input, then what I'll do is I will process that input. Here what can I get from that input? If I ask something, then what is the result that I got it? I'll process that input, and then there might be a possibility that again I'll go for a printing. Here, okay, fine, previous query gave me this answer, now do this query, right? So let me take an example. Let's say the question says that you have been given a sorted array, or let okay, right now let's ignore the question. So we'll do the question, you'll understand it pretty easily. It's not a big topic. The main thing is about printing, about in taking input and giving output, how to interact with the judge, right? That's the main thing. So basically, if your solution makes queries in a specific way as required in the problem statements, you will get an accepted verdict, right? So basically most of the times we have an upper bound on the number of queries, that you can ask these many queries only, right? And so if we exceed the given number of queries, then there may be any verdict. It may be a wrong answer, it may be a time limit exceed, it may be any other verdict, right? So what we'll do is we'll try to understand that how we'll interact with the judge, right? So right now I will be doing it in C++, and you can also do it in Java and Python. I'll give you the instructions. Interacting with the judge, right? So guys, the first thing that we need to understand at the time of interaction is that when we print something on the screen, print output on console or screen, we can say it anything, then what happens is that the output gets printed and the compiler reads it. It's an expensive process, right? It takes time, it takes a lot of time, right? So what actually we do is we try to make a code run a little faster. How do we make a code run a little faster? So what does this languages do? These languages try to store the output that our code actually printed. They actually store that output and it is called buffer output, right? So they store the output in a buffer, right? And in the end, that is when the program terminates. When the program, I will give you an example, I'll run it also on the screen. When the program terminates, then it prints all of the output at once, right? At one go, right? So you understand what I'm trying to say over here, right? I'll give you an example, I'll code it also and I'll show you that what actually I mean. What does this at one go mean? It is printing it in one go, right? So what actually happens is when we are trying to interact or whenever our code prints something on the screen, then the language stores the output, right? And that's called a buffer output. And in the end, like let's say we have many test cases, and after a test case we need to print the output. So instead of printing that output on the screen then and there only and then moving on to the next test case, what it will do is it will store that output in a buffer, and then after all the test cases have been performed, the code has been terminated, then it will print all the output on the screen, right? So instead of going in after every test case, it will just go after the termination of the program, right? So there will be only one time that the output function will be called, so that will make a program a little faster. I have seen this that many of you must have used the function iOS base thing with stdio, right? That actually does this operation only. We'll see, we'll also code it, right? So what happens is in usually this happens in the normal program, normal running of a program, right? Execution of a program. But is this worth it, guys? Do we need it? Do we need it? Will it cause us trouble, any trouble, right? If the program terminates and prints all the output at one go, it will cause us trouble. If I am trying to code an interactive problem, because what does an interactive problem means? That we'll print an output, right? We'll print an output, then I'll get an input, right? And then again I'll print an output, and according to that output I'll get an input, I'll get a response from the judge, right, guys? So it will cause us trouble, na? I cannot print all the output at once in the end, because if I try to print all the output at once in the end, then how will I get the input, how will I get the responses, right? So it will cause us trouble to code a interactive problem this way, right? So what we'll do is we'll use some flushing commands, right? So what does those flushing commands do? After performing any output, after printing, we will say that the program will tell the program not to store the output in a buffer. We'll say it kia just flush it on the screen, flush the buffer on the screen, right? Ki don't store it. Let me give you an example to make it more clear to you all. So basically let me write a small code and then you'll understand. Let's say we have test cases, right? And in each test case what I'll do is for each test case I'll go take a input n integer and I will just write an output that n is okay. And right now guys, I have used a slash n over here, right? I just want to make you understand what is the meaning of a buffered output, and then you'll understand some new terms which you have been already using but you do not know why those works, right? So let me just build it in the command prompt, right? I am not using this input output thing right now, okay, because I want you to understand this thing. So I've opened the command and I'll just move on to the directory. Let's move on to this directory codes. Here I have saved all my codes, right? So we are in the codes, right? Now let me just compile this program, this file new.cpp. So g++ new.cpp new.exe, right? Let's compile this file and let's wait for any errors. No errors. So the file has been compiled and it has an executable file has already been made, right? It is new.exe. So let's run new.exe. So basically my this program is running, right? So in this I have test cases. Let me write 5 test cases, right? And after that we have an input n, right? So let me write 1. So n is 1, 2 n is 2, 3 n is 3, 4 n is 4, and 5 n is 5. So you can see guys what actually is happening ki when I am trying to print 1 and it says n is 1 and then it is going on to taking 2, right? See, it is taking this input n and it is printing this. Here the n is 1 and then it will go on and take the input, right? Right. So before moving on to the second test case, before inputting this 2, it actually prints 1 over here, right? That is what is happening, right? But sometimes what we do is we use these lines. These are iOS based sync with stdio and syn.null, cout.null, right? So these lines will actually help me buffer up my input and output, right? So now we'll try to understand here what are the use of these lines. Some of you might have been using these lines and we all know here, of course, if I use these lines my code runs like 2 times faster. If the time was 1 second of execution, then it will run in 5 seconds of execution. Why? Because the input and output is actually a bigger task. And you must have also seen in various problems it is written here if the input and output contains large input output, right? It contains a large set of input outputs, so use faster IO methods. So these are the faster IO methods, input output methods, right? Let's see what change does this do in our code. Let's try to build this code again, okay, and let me run this code. Okay, now we have this 5 1. See guys, nothing has been printed. 2, nothing has been printed. 3, 4, 5. Now we can see that everything is printed at once. N is 1, N is 2, N is 3, N is 4, N is 5. I hope you are getting me now what I meant from printing first and then taking the input, right? So as we can see, it's a live example from when I input 1, then I outputted 1, and then I input 2 and then I outputted 2, right? But here I've been taking 1 as input, then 2, then 3, then 4, and then it is printing n is 1, 2, 3, 4 and 5. Why so? Because the output is actually being saved in a buffered output, and when the program is just going to terminate, the buffer output clears itself up, right? Whatever the output is there, it will clear it. What does clearing a buffer output means? It will print it on the screen. I hope you got the difference of adding these 2 lines in the code, right? So it becomes easy now because output function is being only called once. So the compiler that is on the other hand, right, wherever we are trying to submit our question, the compiler will only take this whole as an input and just check with the favorable output and tell us whether it's right or wrong, right? Otherwise the compiler has to, right, give this input, then check the output, then again give the input, and then again check the output. It becomes hectic and it's expensive operation this way, right? So these 2 lines, the work of these 2 lines I have already told you right now. Now guys, we do not want this. We want our program to work in this way, right? It buffers the output, it flushes the output, right, after every cout call. Whenever I say a cout, then it actually prints on the screen, it doesn't store it somewhere else, right? So what I do is, we have some manually flushing operations. So this is fflush stdout in C++ if I'm using printf and scanf. So if printf and scanf I am using, we can use fflush stdout. It will flush standard output, right? Otherwise I'll use cout flush in C++ if I use scene and cout. I'll show you the example, working example. And in Java we can use system.out.flush, and in Python we can use stdout.flush. After printing anything, just flush the buffered output, so that whenever I'll take the next input, it should be according to the interaction, right? It should be according to the interaction, because if I'll output something, then only I'll receive an input, na? This thing. If I'll give an output, then only I'll receive an input, right? Okay. Okay, now let's see the difference. Now what I'll do over here is, instead of /n, or let's use /n, then what I'll do, cout flush. Let's flush the output, right? Now let's build it on the command prompt. Okay, it's been built. 5 1, see, just I've used one line cout flush, and now it is working my older way, right? This way, the upper way that I've already defined you all. It is working according to that way, na? It is taking the input, then printing the output, then it will take the input and then print the output, right guys? I hope this makes sense to you, right? What is a buffered output and why do we need to clear it? We need to clear it because in an interactive problem we want the answer. We want the answer for a particular query, and if I'm trying to ask a query, I'm asking it by printing it something on the screen, and the other judge is reading that output on the screen and giving me the answer for that particular query that I'll input, right? So I use cout flush. We can also use fflush stdout in C++, right? If I use printf scanf, otherwise you can use cout flush. And now let me tell you a smaller way to like a shorter way to use in interactive problems. We use a end line, that is ANDL, right? So what does an ANDL do? Always remember, this ANDL actually works as cout /n and st, or cout /n and then flush, right? So if I do a /n and then I do a flush, /n means move to the next line, and flush means just flush the output. Whatever there is in the buffered output, just put it on the screen. So ANDL actually works both of them combined, right? So what will ANDL do? It will actually flush the output. So we have seen that if I use /n in my code, it works a little faster, and if I use ANDL in my code, it works a little slower. Why? Because it is actually flushing the output after every cout call, right? So let me build this function again, and right, now see, 5 1 2 3 4 5, right? We are getting it the same way, right? If I don't use this ANDL, guys, what will I get? If I don't use this ANDL, I'll get this second way, right? Because ANDL is actually flushing the buffered output, right guys? Now let's not use ANDL, then let's see what happens if I just write an n. Let's not also use /n, so nothing will happen. We'll just get everything in a similar line. So I hope you got the working of ANDL, how ANDL actually works. It is flushing the line, so we don't have to use fflush stdout or cout flush every time again and again. We can just write ANDL, right, after every cout call, right? So let me just build it quickly, and after that we'll see 5 1 2 3 4 5, right? So n is 1, n is 2, n is 3, n is 4, n is 5. It is being printed in a same line because of these function calls, right? So actually this I have written in my own way, right? Just to explain it to you. Most of the time online compilers use these functions use these functions so that they can execute your code time. Right? Why do they need to execute your code time? Because during a time of a contest, many participants are like printing it on the screen, right? Many of them are submitting the answers, the solutions, right? And to fasten that up, like to save time, so that the compiler doesn't get hang and there isn't a long waiting queue, they use themselves, right? These functions in every code. So what can be the best way then? After printing anything, we'll just say endl so that it prints on the screen. We are flushing the output. I hope you got why is endl flushing the output and what is the use of these functions and why are they increasing the execution time, right? Okay, so this was it. In the next video we'll do a question and we'll be using these flush outputs. Then you'll understand what actually is a uh, interactive problem, right? We'll get an example. So in the next question I'll be doing this question, guess the number. It's from an interactive problem training contest. You can see this, you can copy this link, go to the problem, read the problem yourself, and then let's see you in the next video, right? Okay, thank you. Hello guys, welcome back to the interactive problems second video. And in this video what we'll do is we'll see some working examples and we'll also code interactive problems. Now it's time to do examples, right? So I said that we'll be doing the question and you can copy the link, open in your laptop, and first of all you should go through this yourself, read the question, it's your responsibility, and read it properly. You can make queries to the testing system and all this, flush output stream, and these are the inputs that you will receive. Like if we're asking for a query, in every query we'll have to print a number x, and then the other person, the judge, will give me whether that number is less than the given number that we need to find or it is greater than the given number that we need to find, right? Greater than equal to, right? So when your problem is show that the guessed hidden number, the number, if it is like, okay, so normally what I'll do is I'll just print a simple number, right? And in the end what happens is if I found the answer, I'll print 12, right? Let's see how this interaction is actually working. Okay, so how this interaction is actually working. So first of all what I did is I tried to print 8. I printed it. Okay, this is me and this is the judge. So I printed it and the judge said that the hidden number that the answer that I have to finally find, hidden number, it is actually greater than equal to 8, right? Hidden number x. Okay, then if the number is greater than equal to x, then the number should be between 8 and 10 की power 6, because 10 की power 6 is the total strength of the numbers, right? Yeah, 10 की power 6. Now what I did is I printed 20, right? And then the interactor says fine, this 20 is less than the given hidden number x, right? Still I haven't reached the hidden number. Now I printed 11. It says again 11 is greater than equal to the given number. Then I said 12. It says again it is greater than equal to the given number x, right? So basically what happens is that this number x is greater than equal to 8, this number x is less than 20, this number x is greater than okay, greater than equal to 11, and then this number x is greater than equal to 12, right? Then if I printed 13, see this 13 and this output, if I printed 13, then it says fine, now this number x is less than 13. So if it was greater than equal to 12 and it is less than 13, so here I got the answer. My answer should be 12 itself, because 12 is the only number that will satisfy all the properties, right? Now that's not the problem. This is a basic interactive problem. The main problem in the solution is that we cannot ask more than 25 queries here, right? See, the numbers are 10 to the power 6. We could have started from 1 and we could have checked the first position where I have got less than sign, because the first position where I have got less than sign, the number before that will be my final answer. as in this example I got it 13, right? So if I'll start from 1 and then 2, 3, 4, 5, 6, then when I'll reach 13, I'll finally get ki- I'll finally get this value less than, right? Because the hidden number was 12. So if I make it on a number line, let's say I start from 1 and I go to 10 to the power 6, then this number 12 is over here, right? So if this number 12 is over here, then for a number between 1 to 12, what I'll get, the interactor will give me greater than equal to that. The 12 is greater than equal to all these numbers, right? So for 13 only, 13 is the first number where I'll get less than, and after 13 till 10 to the power 6, 13 till 10 to the power 6, I'll get less than sign, right? Not less than, equal to, less than. I hope you're getting me, right? Here I'll get greater than equal to, and here I'll get less than. I want the first index where I'll get less than, the answer will be -1 of that. Otherwise I want the last index where we get a greater than equal to sign. It's the same thing, na? Right? So guys, how will I find this number in only 25 queries? Think about it. Think about divide and conquer. Think about binary search, right? We only have 25 queries, na? We can't query from 1 to 10 to the power 6. There will be 10 to the power 6 queries. We just have 25 queries, right? So what I'll do is I'll binary search for the answer, right? Let's say 1 and 10 to the power 6. This is my left initially and this is my right initially. So how do we binary search for the answer? I say let's say x is over here and this is the current middle, right? I hope you're well aware of binary search. So for this middle element I'm trying to find the answer. So I'll query middle. I'll query this middle. Okay. Now when I query this middle element, it will return me either greater than equal to, or it will return me a less than, right? These are the two possible answers for this middle value. So if it returns me greater than equal to, what does this mean? That the current element is greater than equal to x, x is greater than equal to the current element. That means I need to search on the right hand side, right side right side of the binary search. I hope you're getting me. You can pause this video and, like, it's not a big logic now, right? It's a very simple question. Just the ways, the important thing is I'm just trying to explain you how to code it, right? If that number is less than, means x is less than middle, then what I need to do is I need to search on the left side of the binary search, right? That's what will happen. Eventually I'll reach on the x element finally, right? By jumping again and again in the binary search. So if I have 10 to the power 6, so what will be the total complexity of the queries? If I try to binary search it, it will be log n, log base 2n. So what is log base 2n, 10 to the power 26? It is approximately 2021, right? And I further have 4 more queries. There are 25 queries, and I actually don't need those 4 more queries, right? I can only answer in 20 to 21 queries, right? So I hope you got this, right? Let me just make a quick example on the given number 12. So this was 1 and this is 10 to the power 6, and let's say x is 12, right? So left, right, middle. So left is 1, right is 10 to the power 6. What will be the middle? It will be left plus right by 2, that is 5 into 10 to the power 5. So if I query for 5 into 10 to the power 5, it will be somewhere over here, right? And it will return me a greater than sign, that yeah, this sign, less than sign, right? Ki x is less than this number, right? So what will happen is I'll make right as middle, right? So right becomes now 5 into 10 to the power 5, and left becomes how much? 1 only. Again I'll search for the middle element. It is 10 to the power 5. Again I'll search for the middle element. What I'll get is I'll just divide it by 2. It will be somewhat like 250000, right? And again I'll move on. I hope you are well aware of the divide and conquer binary search thing. It's the same thing, right? Now let's see how will I code it, how to code it using interactive problems approach, right? Okay, so this is the problem 1, and then we'll see how to build it in our compiler, in our current compiler, right? So there are no test cases over here, right? And guys, what is this input over here? This input is actually what we are printing, right? What we are getting from the judge, and this output is actually what we are printing, and then we are getting the input, right? So what I'll do is I take left equals to 1, then I'll take right equals to 10 to the power 6. We have these two numbers, right? And I'll say while left is less than right, what you do is find the middle element, right? So what is middle element? Left plus right by 2, right? Now give me a string for the middle element, right? So let's make another function so that we don't have to worry about the query, and let's make it an integer type of a function, right? So I'll just tell you a simpler way to query all interactive problems. Otherwise you have to write this again and again, like wherever you are trying to query it, you have to write it again and again in the code, right? So let's say the query function returns me an integer, and it takes me the integer, right? And let this integer be middle, right? So what it will do is it will just print middle, and endl, as I already explained, endl is very important, right? After this it will input the current character, right? There is a character over here, this thing. So basically it should not be integer, it should be a string type, string resultant, input resultant. So it has inputted a resultant string, right? And after that what will happen? If it inputs a resultant string, then simple, if resultant equals to this small, then let's say I'm returning 1, right? Else I'm returning 2, fine. So it's an integer type. If my query answer for my current query, that middle element, if middle is, or let's say the number x that we are trying to find, if it is less than middle, right? If x is less than middle, then it will give me a less than query, and for less than query I'm returning 1, right? And if this x is greater than equal to middle, then it is returning me a 2, right? So basically I've converted my query into an integer type so that it becomes easy for me to handle, right? So if query middle equals to 1, else, otherwise it equals to 2, right? So if query middle equals to 1, then I have this situation that x, the number that I need to find, is on the left hand side, right? Somewhere behind, it is less than middle. So for this what I need to do is I'll say yes, go on the left hand side, and I'll say here make right equals to mid minus 1, right? Because I don't need the middle element, I'll just reduce my range, right? And otherwise what I'll do is I'll say left equals to mid plus 1, and here I'll say here, okay, see there are different types of implementations of binary search. I'll say now I'll just make left is less than equal to right. So whenever I'm getting a first type of a query, I'll move on the left hand side, and whenever I'm getting a right hand side of the query, I'll move on the right hand side, right? So what I need to do is simple, ki whenever the query is being possible, I'll save it in my answer, right? Comma answer equals to 0 initially, and let's say answer is middle. So this answer will actually store the final answer that I need to print. Okay, let's try to build it. Okay, right, this middle should be middle. And any more errors? Oh, okay, this is a string, not a character, right? So basically I haven't given any input right now, so that's the main problem of the interactive problem. You cannot, like for big inputs, you cannot check it yourself, right? So let's say first we got this, and after this I'll just okay, let's say my final answer is 12, right? Let's say our final answer is 12. So this 5000 will be greater than equal to 12, so 12 is less than this, right? Again it will be less than. Let's write many less thans so that we can understand. I'm just trying to hack it now, right? I'm just trying to move to the final answer. Okay, I've just written less than. See, you can see the values are changing, right? So again less than, let's do less than, right? Why am I doing less than? Because every time there's an output, every time there will be an output, and yeah, whenever there will be an output, I'll input an another input, right? So it is always going less than, so it will finally reach somewhere over here, right? After 17 steps I am over here, after 17 inputs and outputs on 7, right? So let's do one thing then. Let's till 16 let us do less than, and otherwise we'll do greater than equal to, right? And let's see what's the change for the output we get. Okay, so we are 13, then we came on 15, then we came on 7. For 7 it gave me a greater than equal to, and then it printed 11, right? So for 11 also it will be greater than equal to, right? And it will print 13, it will be less than then. So let me just check it again, right? And again, see, now for 13 it gives me a greater than equal to sign, right? So for 7 we had greater than equal to, for 11 we had greater than equal to, and for 13 we had less than, right? And then it printed me 12, and then again I'll say greater than equal to, right? Okay, so for all these numbers, if my query is 1, so if my query is 1, should I move it to my answer? Should I say ki answer is equals to middle? I shouldn't say this, right? Answer should be equal to middle here, right guys? Why over here? Because it is greater than equal to, na? It can be the possible value, right? So I'll say answer equals to middle over in the else part, right? Because if the middle is less than that, I cannot make that equal to the middle, right? Okay, now what we'll do is, finally, whenever we need to print the final answer, we'll have to print a sign, right? This sign, it's a exclamation mark, right? Okay, so we got an answer over here, and then finally I'll flush it also so that it takes the answer, right? So we got a 12 over here. I hope you got me. Why did I make so many less thans and then these greater than equal to's? Because we need to debug our code ourselves, we need to check our code ourselves. There's no other way, right? Because it's an interactive problem. Okay, right? Now let's submit it. Let's try to submit it. Okay, new.cpp and submit. Guess the number, right? Let's see if it works or not. Kids on desk is 3. I hope you got me, guys. This thing, right? Why do I need to print an ANDL over here? This is the most important part of interactive problems, because yeah, questions, there are many questions, every question has their own unique approach, because it restricts us to give a particular type of a query, right? We cannot query anything, we cannot query any English, right? We have to query according to the asked queries, right? And we have to think in such a way that after taking all those queries, how can I maintain my final answer, right? So I hope this thing is clear to you guys. This question, guess the number, it's a most easiest interactive problem I have ever seen, right? A simple binary search problem. I hope the implementation part is clear. That's my job over here, right? And after this I'll be doing a little more tougher question, right? The logic will be tougher, of course, and then we'll do it. Okay, so guys, thank you. See you in the next video. Hello guys, let's do a problem. It's a easy problem on interactive questions. So first of all, we'll do this problem, lost numbers from Codeforces, and then we'll move on to XOR guessing problem from Codeforces. and this is a easy problem, and after this I'll be just taking a little advanced problem, right? So the purpose of these videos is just to make you understand how to deal with interactive problems, right? It's not clear after looking at 2-3 videos you will be able to do all the interactive problems yourself. The purpose, the main thing that I want to tell you is how to code the interactive problems if you know the logic, right? And that logic discussion part, like you will get many interactive problems on your way. See, you can just go to problem set, right? And in the problem set you can filter it with just add a tag that is interactive, right? And you can filter this all the problems, and after that you can practice those problems according to the difficult device, right? These problems, right? So if you're a beginner, try to do 1400 problems, then 1500, then 1600 problems. You can even filter them accordingly, 1400, 1500, and so on, right? So what I wanted to tell was that every interactive problem has their own unique way, right, to deal with. And moreover, in an interactive problem, our thinking is actually limited, right? Why it is limited? Because in the question itself it is given that you can only ask particular types of queries, because the queries, there's only some particular types of queries, right? Like, for example, in this question it's given that you can ask a query of AI into AJ type. You will be printing I and J, which are two indices, and then you will be getting an integer that is AI into AJ. So this is a type of a query. So if you have a query of like AI into AJ, then you cannot think the solution. You can start thinking the solution by AI plus AJ, right? Our thinking is actually limited, na, because of the queries we can ask, because of the types of queries, right? Because yeah, so by doing in interactive problems and by looking at which type of queries we have, we can just find a way. Yeah, this is the way I should go on. I should first start here. What does this AI into AJ, right? So guys, I just pause this video for a minute or two and try this problem yourself. It's an easy problem. I'm just here to like make you understand how to code it. You can also do it yourself. It's really very easy. It's just 1400, pointer 1400, right? One of the easiest problems I have met, interactive problems, right? So the first paragraph is just to make you understand what are interactive problems that I have already made a video on. The second paragraph and the third paragraph are the main questions, right? So the question says that you are being given six spatial numbers, right? These, we have six spatial numbers, and each of these numbers occurs in a exactly once. Okay, so you have an array consisting of six integers, and what are those integers? 4, 8, 15, 16, 23, 42, right? Yeah, so we have an array, and we do not know that, we do not actually know the order of these elements in the array, right? So if I have six elements in an array and all the elements are unique, so how many ways are there to permute this array? It is 6 factorial ways, right? 6 into 5 into 4 into 2 to 1. So this is how much? 120 into 6, okay, 6, 5, 30, and 120, 360, and 720, right? So we have 720 ways of making this array. Out of those 720 ways, I have to exactly find my array, right? See, to give the answer you must print one line, that is this exclamation mark, a1, a2, a3, a4, a5, and a6, all these numbers in the array with a line break in the end. After that it should flush the output. Yeah, that is the thing we have already discussed of flushing the output. Now let's read this paragraph, right? So you do not know anything about their order, but you are allowed to ask up to 4 queries. I hope you have read the question, right? I'm just going through it again. In each query you may choose 2 indices I and j, and you will get the value of AI into AJ in return. Can you guess the array A? Well, so we have to guess the array. Out of those 720 options, we have to find the exact array, and what we can do is we can just ask the queries AI of the type I and j, which will give me AI into AJ, right? I'll get this value in return. AI into AJ, right? So let's get on with the first example, right? Let me make a snip. Right, so here we have. So firstly I asked the interactor here, tell me the multiplication of a1 into a1, right? It is a1 into a1. So what I have is, on first position we have an 4, an integer 4. So 4 into 4 is 16, right? So I got an input 16. That interactor sends me the input in 16, right? Here you have this, the multiplication of a1 into a1 is 16. And second I have 2 into 2, right? So 2 into 2 is this. So a of 2 into a of 2 is how much? 8 into 8, 64, right? I hope you got it. What does this query means and what is the input that I am trying to get, right? So now let's try to think of a solution, which type of a solution we can have over here. So if I have this AI into AJ type of a thing, then let's see here, if every, like, if I multiply all these pairs, right? 4 into 8, 4 into 15, 4 into 16, let's see will I get a unique answer or not, right? So if I get a unique answer, then it will become a little easier for me to think it more, right? Because there won't be any ambiguity, right? Just wait and you'll understand. So let's make an array or a vector v, and let's copy these elements, right? And after this let's run two loops, right? And so we made a vector, and now I'll just check the multiplication of all the numbers of all the pairs, right? Let's start from I plus 1, right? Now let's check the multiplication of all the numbers, whether that will be unique or not, right? So build it. So if the multiplication of all the numbers is unique, then I can like think of something, right? Because if the multiplication of all the numbers is not unique, then I will have to think of that ambiguity, like how to deal with that ambiguity, right? Because if I ask, okay, what actually I want to say is here, if I ask a query ki give me I and j, right? Multiplication of I and j, and it returns me with a value that is equal to ai into aj, right? Okay, so let's assume I asked this 1 and 2 and it gave me 32, right? So I do not know na ki whether on 1 I have 8 or on 2 I have 8, right? It can be 8 4, it can also be 4 8. There's an ambiguity over there na, right? And furthermore it is 32, so there is a chance that any other pair may also give me a 32 result. Multiply them, right? So that's what I'm trying to check, whether I have to deal with only these two things, that is 4 8 and 8 4, or would I also have to deal with some other numbers x y and y x, right? So that's what I'm trying to check over here right now. So I've got these multiplications, see, two digits, they are all unique, right? And then 1 6 1 2 1 8, that's unique, yeah. So yeah, I can see that all these numbers are unique. Multiplication of all these numbers, all these 6 numbers, right? So there are how much? 62 pairs, right guys? So all these numbers are unique, the multiplication of all these numbers. So I can, now I don't have to deal with a second type of ambiguity. I don't have to deal with this type of ambiguity, right? If I ask some AI into AJ, then I will 100% I will be sure that whether it will be a 4 into 8 or it will be a 8 into 4. I can easily find out that pair, na, which pair is giving me that multiplication, right guys? Okay, so this was the first thing. Now let's move further ahead. So he says that you are allowed to ask up only four queries of AI into AJ, right? So what we can do is, if I don't have to deal with the second type of ambiguity, then what I can do is, guys, total how many I have? I have 6 factorial, that is 720 permutations. So guys, I can make all the permutations in C++, right? What are the ways of making, means you can code it in any language, of course. So in C++, what are the ways of making all the permutations? We can do it using recursion and backtracking, right? There's a one way. And we have a STL function which is called next permutation, right? We can use that function next permutation to make all the permutations of this array, right? I'll show you how to make it. So guys, if I try to do this way, ki yaar, I'm asking 4 queries, okay, and the first query will be ki give me the answer at 1 and 2, second query 2 and 3, third query 3 and 4, and fourth query is 4 and 5. If I do this, then I'll get a 32, I'll get a 8 into 15, whatever it is, right? And I'll get these 4 numbers, right? This and this. So guys, if I have these 4 numbers, I have the first 4 terms. So in short, guys, I have actually fixed the first 5 numbers. How, guys? How have I fixed the first 5 numbers? See, by these 2 queries, 1, 2 and 2, 3, I can easily determine these numbers 4, 8 and 15. Why? Because from 32 I'll have 2 options, whether I'll have 4 or 8 over here or 8 and 4 over here, right? And from 2 into 3, what is that? 8 into 15, right? So let's take it out. It's I guess it's 120, right? So 120, this will give me 2 options, whether it can be 8, 15 or 15 into 8, because there's no other number from 120, right? So out of these 4 options, only these 2 options fit, right? Here it should be 4, here it should be 8, and here it should be 15, right? Similarly, guys, if I have found these 2 numbers, now I can easily find these 2 numbers, right? Because I have 3 into 4, right? From 3 into 4, if I have the third number, I'll easily get the fourth number, and if I have got the fourth number, then from 4 into 5, the number that I have, 4 into 5, I can easily get the fifth number. How? Simple. If I have this value, guys, 4 into 5, let's name it Z. So if I do Z upon this fourth number, that is 16, I'll easily get 23, na? Right? And if I have these 5 numbers, then there's only one number remaining, that is 42, right? I hope the logic is clear to you guys now. What I'll do is I'll ask the first 4 consecutive queries, these types of queries, 1 2 2 3 3 4 and 4 5. So by these 4 numbers only, I can easily determine first 5 numbers. If I have easily determined the first 5 numbers, then the 6th number is only one number, right? Because it's the only remaining number. So let's do it, guys. So what I'll do is I'll try these 4 values for all the permutations, and for whichever permutation these 4 values will satisfy, I'll print that permutation, right? So I'll try all the 720 permutations possible. Whichever permutation fits these 4 numbers, right, I'll print that permutation, because it's guaranteed that these multiplications are distinct, the values are distinct. That's what I checked initially, right? These values are distinct. Okay, so let's code it then. So basically, let's not erase this vector, we'll be needing it, right? So what is the interaction type? Let's see the interaction type. Before submitting the answer, you may ask up to 4 queries. To ask a query, print the format question mark I and J, right? So let's say 4 numbers, right? Let's take 4 numbers, and if you're not comfortable with vector, you can also take it as an array, right? It's do whichever way pleases you, right? Vector int a, right? So let's take 4 queries, right? And or fine, I'm taking 0 based indexing, so whenever I'll go for a query, let's make a function and let's say give me the query, right? So int query, So this function will return me what? It will take input I comma j. It will take input two parameters, right? And it will return me a ai into aj. It will ask the query and return me ai into aj, right? So let's print I and j and then handle as we already do. So I'm printing I and j. Then what I'll do is I'll say answer, I'll input answer and I'll return this answer, right? So our query function is complete. And after that what I'll do is simple, just ask these queries, right? So int q equals to give me a query I plus 1 I plus 2. Do remember guys, I started I from 0. I have actually done a zero based indexing, right? But the compiler, the interactor doesn't know na that I am using that zero based indexing. So it wants I and j to be between 1 and 6 only, right? So that's why I've sent I plus 1 and I plus 2, not I and j, right? So ai equals to query I plus 1 and I plus 2, right? So ai is storing the multiplication of ai plus 1 and ai plus 2 with a zero based index, right? I hope it doesn't confuse you. Now let's make all the permutations. So this is the way we can generate all the permutations in a vector or a array, anything. So we'll do a v dot begin till v dot end. So this will generate all the possible permutations, right? So let's try to print the permutations, and then because some of you might not have been familiar with this function, next permutation function, so we can easily see. So guys, whenever these 4 lines are for asking queries. So if I'm asking the query, then there is one more thing that I need to do. What is that thing? There should be a question mark, right? There should be a question mark in front of the query. So let's make a question mark over here, right? Now it's fine. Yeah. And after this what I have done is I have printed all the permutations possible, right? So all the lines are these lines, printing of the permutations, right? You can try this, it's a very neat stl function. Okay, so now what I'll do is I'm trying all the possible permutations, and whichever permutation satisfies my this array ai, I'll print that permutation, right? So what I will do is simple, let's iterate over all these, or let's go over 4 values only, right? So if ai equals to a okay, if ai equals to vj into vi into vi plus 1, right? Because this vector contains a permutation, right? So if I say v0 into v1 equals to a0, then it's well and good, right? There is no problem with it, right? So let's take a boolean variable called can and initialize can with 1 key. Yes, that this can be a permutation, right? And if this property does not satisfy it at any of the index, then I'll say can equals to 0, right? So finally guys, what will happen if my can equals to 1 at this point, right? That it has never become 0, that means I found the permutation, right? Then I have to print the permutation, right? So I'll just say cout okay, and cout x. I'll print all of them, and finally what I'll do is I'll say return 0. I'll just break I'll just go out of the int main, I'll just finish my program. Okay, not count, it is can, right? Okay, so right now there is no can that is satisfying my need because I haven't given any input, right? So let's give an input according to the this question, right? So let's give this input. So it is 1 into 2 over here is 4 into 8 is 32, then 15 into 8 is 120, and 15 into 16, right? So 15 into 15 is 225, and it is 241. 242. No, 240, right? Yeah, 225 is 15 into 15, and plus 15 will be 240. And after that I have 16 into 23, right? So how to find 16 into 23? Simple. See out 16 into 23. Okay, 368. 368. So I have these first four terms of the permutation, this permutation, right? And let's see if I'm getting the output or not. Yes, I'm getting the correct output, right? Because when this permutation was being formed in the next permutation, right, then only then these four values, first four values satisfied my first four multiplications, right? So if first four multiplications are satisfied, what does that mean? That first five numbers are fixed, and if first five numbers are fixed, that means there's only one number 6 remaining, right guys? So it was an easy question, and let's submit it on Codeforces. Actually, during the time of the contest I have already uh, done this, and right, okay, it's on 2. Let's check there are errors or not. Yeah, see, it's an accepted code. I hope you understood it. See guys, the most simple thing is that there are enormous logics, right? Every new question has its own logic. I have never seen a logic repeat. I have seen combinations of logics repeat, but I have never seen a single logic repeat itself in Codeforces, in CodeChef, right? So to prepare that logic, you need to do more and more questions, right? And to know how to code it, we are there for you, right? If you face any problem in coding part, in implementation part, we are there for you, right? But we cannot make that many logics for you, because in future also you will be facing those many logics, yeah? Because always there will be new questions, and if there are new questions, there will be new logics, right guys? So for that you need to practice and practice. Okay, so in the next video we'll do another question from Codeforces itself, and it's a good question, a very good question, right? XOR guessing question, right? So see you in the next video guys. Right, as I said that we'll be taking a problem from Codeforces, and its name is XOR guessing. You can just go over this link and pause the video and think about this question yourself. After that I'll be discussing this question, right? The question is not that easy. It won't come to you suddenly, it won't strike you, right? You should devote like half an hour or 1 hour for this question, because it's an question from a Div2 contest, right? So I've taken one tough question just for you all to know, yeah, how different types of questions can be made by interactive problems, right? So what does the question say? That the jury has a integer x and it is not less than 0. That means it's a positive integer between 0 and 2 to the power 14 minus 1, right? Basically it's a 14-bit integer, right? So you have to guess this integer. Fine. To do so, you may ask no more than 2 queries. Each query should consist of 100 integer numbers a1 to a100, right? So what does each query should have? It should have these numbers a1 to a100, right? And each integer should not be less than 0, and it should not be greater than 2 to the power 14 minus 1, right? So we have a limit. Between these limits we have to print some integers. How many integers? 100 integers, and it should be exactly 100 integers, right? And all these 100 integers, right? So we will print 100 integers in the output, and the jury will respond with the input, right? So what will be that input be? It will be ai XOR x. So what is x? X is the number that jury has picked. So what will jury do? The number x that it has picked, it will try to XOR with all the numbers we have, right? So the question says that the jury will pick one integer. it will pick one integer I. That means out of all the 100 numbers that I have given to the jury, it will pick one, any one of them at random, right, and give me ai's or x, right. And there's an additional constant on the queries. All 200 integers you use in the queries should be distinct. So you cannot like print 0 5 times or something like that, right. All those should be distinct. So it is guaranteed that x is fixed beforehand, right. So x won't change according to your queries, right. It's already fixed in the judge, but the choice of I in every query may depend on the integers you send, right. So to give the answer, your program should print one line, that is exclamation mark x with a break in the end, that is of course endl, and after that it should flush the output, right. So guys, pause this and think about it, and then I'll be discussing it, right. The important part is that you can ask no more than 2 queries. That's the important part. Only 2 queries, right. And each query should consist of 100 integers, and all those 100 integers should lie in a particular range, and they should be distinct. See, as you can see, like let's say we read a question and then we have various solutions coming in our mind, right. But this question, it actually reduced all our solutions. Here you cannot do this, you cannot do this, you cannot do this. It wants that solution that it wants. Right. So how will we do it? Pause it, think it, right. And now let's discuss this question. So guys, basically we have a x, jury has a number x, that is a 14-bit number, right. This is a 14-bit number. There may be 0, there may be 1 anywhere, and we'll have to provide an array a of 100 integers between range 0 to 2 to the power 14 minus 1, right. And all of them should be distinct. So what it will do is it will pick any of the ai's and do ai XOR x. You know what is XOR, right? This is the XOR table. So 0 0 0 1 1 and 0. If both the bits are same, then it will give me a 0. If the bits are different, then it will give me a 1, right. That's a XOR table, right. Okay, so right, so it will do a ai XOR x and it will just return me that value, right. So guys, how will I do it? How will I approach this question? Think about it again, and then I'll tell, of course. So what I will do is I will actually so what we can do is we can just divide this x into 2 parts, right. 1 2 3 4 5 6 7. See, what we'll do is we'll divide this x into 2 parts, and we'll try to find the first part in one query and the second part in the second query. How will we do this? We'll use this XOR table, right. So if I print 100 integers, right, whose these bits, the most significant 7 bits, if most significant 7 bits of all those 100 integers are 0, then whatever the integer the jury picks will contain these 7 bits to be 0, right. So if it will return me a x XOR ai out of any of those 100 options whose most significant 7 bits are 0, right. See, whatever will be there, it doesn't matter to me right now. I'm trying to build the leftmost part of the answer, the leftmost 7 bits, right. Okay, so whatever the integer the jury picks, all the most significant 7 bits are 0. If most significant 7 bits are 0, guys, then wherever, let's say x is this number, right, its left side is these bits. Now x or any of the ai's will actually give me 1 0 1 1 1 0 only. There cannot be any other option, right. It will give me this only, na. Why, guys? Because 1 0 or 0 1 is 1, right. So there is 0 on all those numbers on the most significant bits, and 1 wherever the 1 will be there in the x, there will be 1 on the x on those significant bits. So I'm saying that we'll get these 7 digits. We'll get these 7 digits in one query if I try to give 100 these types of integers. Here there can be some distinct values, it doesn't matter, right? But here this should be 0. All the 7 significant bits should be 0. So is, can I make 100 such integers? Yes, of course I can make 100 such integers. How can I make 100 such integers? See, simple. If these bits are 0, then we can place any of the bits over here to make them distinct, right? So each of these places 2 options. So there are 2 to the power 7 numbers, right? And 2 to the power 7 is how much? 128. So we have 128 such numbers from 0 to 127. All those numbers will contain some bits over here, but all of their left bits, the most significant 7 bits, will be 0, right guys? So I'll push 100 numbers from 0 to 127, any of the 100 numbers, to get the leftmost bits, right? From that I'll get the leftmost bits of the number x. Now how to get the rightmost bits of number x? Simple guys, again the same thing. How? If I have taken let's say I have taken 0 to 100, I have taken the numbers from 0 to 100, right? Then what I'll do is, let's say the okay, now I actually want here, earlier I did was here left side the numbers are 0. Now I want on the right hand side the numbers should be 0. I want that on the right hand side, on this part, that is the least 7 significant bits, I want all zeros, right? So if I have taken numbers from 0 to 100, what I'll do is I'll left shift all those numbers 7 times, right? What does left shift means? Simple. Let me write 1 in binary. Okay, so 1 in binary will be this, right? So this is a 14-bit 1, right? If I left shift this 1 7 times, right, then what I'll get is I'll get, right, this 1 is shifted left 7 times, and all these 7 places, these least significant 7 places, they will become 0, right? So I'll take again out of those 100 numbers, I'll left shift all those numbers, and again I'll ask for the second query, right? Now what will that query give me? I hope you have got it now, right? This was the important part, that 2 to the power 7 is greater than 100. So I've got, right, so all those numbers will contain their least 7 bits to be 0, right? All those bits will be 0. Then if I take any of these numbers and I do a XOR with x, right, any of these numbers ai XOR x will always give me how much? Will always give me these 7 bits, right? So earlier I constructed the 7 left bits of x, now I've constructed the 7 right bits of x, right? Then now my question is very simple. It's become a very easy question now, right guys? So I'll combine those two 7 bits, 7 plus 7 is 14. I've got the number that I wanted, right? So let's try to code it now. Let's see how to code it. And fine, let me just erase everything, or I hope you have understood the solution, right? The logic behind it. What am I trying to do? I will take 100 numbers whose least 7 bits are 0, and 100 numbers whose most significant 7 bits are 0, right? So let's do it simply, right? Let's go to the question and see what we have to do, right? So firstly I have to make some queries, and that should contain the 100 numbers. See, the example is not correct, okay? It's given you should submit exactly 100 integers in each query, okay, right? So let's make a query, or fine, let's make a query. How to make a query? Simple, cout and a question mark and printing integers from 0 to 100. So we have these 100 integers, cout I, right? So this is the first query, and then finally I'll print endl just to flush the output, right? Okay, so after this query I have an integer x, and I have got, okay, x is the final answer. Then let's just make something answer. We'll input this answer here. give me the answer to the first 7 queries, right? So right now what I have done is I have printed these numbers whose 7 most significant bits are 0 and right bits are something distinct, right? So if the judge takes a number x and do XOR with any of these numbers, x will be accurate for the 7 most significant bits, right? 7 most significant bits will be proper. So how will I get it? How will I get the 7 most significant bits? Simple. Let's run a loop from 7 to 14 and let's take x also, that is the final answer that I'm going to make. Initialize it with 0. So if the if answers ith bit, that is the bit from 7 to 14, if this bit is set, then simply it means only one thing, that of course that bit will be set in, see, this is the answer, this is answer, right? This is answer. If that bit is set in answer, it simply means one thing, that x is, that bit should also be set, right guys? So what I'll do is, if answers that bit, the ith bit from 7 to 14, if those bits are set, then simple set that bit in x also, right? So how will I do this? Simple, one left shift I. So x, that bit is also being set, or we can do XOR or we can do plus. I hope you are familiar with the bit masking operations, right? These are good operations. So I have made an answer x till now. I have made the most significant 7 parts of x. I have just used one query. Now what I need to do is, I need to do a second type of a query, right? And in this query what I'll do, I'll just left shift this printing I, how much time? 7 times, right? So I'll left shift it 7 times. Okay, so let's say count equals to I and count left shift equals to 7. So by doing left shift, what I'll get, all the bits on the right hand side will come on the left hand side of that number, right? And all the right hand side 7 bits will be 0, right? Again I have got those distinct numbers, right? I'll simply print count and I'll do a AND operation, right? Okay, so I is not declared over here, let's declare it, and I is also not declared over here. It's not declared over here, right? This is my second query, right? I hope you got it why I'm doing it 7 times left shifting, so that the least 7 significant bits now become 0. So the rightmost 7 bits, I made it, yeah, now these are 0 and these are not 0, right? These are some 1 1 something 0 1, right? But all the numbers, all the 100 numbers that I'm printing, all 7 these 7 bits are 0. So if the jury picks any of these numbers and do a XOR with x, right, then wherever on the right hand side of x, wherever we'll have a 1, we'll also get a 1 in the returned answer, right? As similar to the above logic. So simple, simply input answer, and again I'll do this this operation. Now for which bits I have to do these operations, guys? I have to do these operations for the 0 to 7th bit, right? Okay, so if from 0 to 7, if these answers this bit is set, then simply set it in x also, right? And finally cout answer, right? This is the way, right? Okay, you can ask 2 queries, the answer will be 1 into -1 if okay, the line should be ended. See, I've done it a long time before on 22nd August, right? So ANDL is necessary, right? ANDL is must, right? So now let's try to build it. Okay, so first we have these numbers and it is from 0 to 99, and then it is printing 0 again. So here we don't have distinct numbers, right? We haven't got distinct numbers over here. So what we can do is, instead of going from 0 to 100, let's go from 1 to 100, because 0 left shift how many times will be 0 only, because there is no set bit in 0. Right, now let's see. Right, so 1 and then 128 over here. 2 left shift 7 times will be 2 to the power 7 is 250. Yeah, so 2 to the power 8 is 256. I hope you got this. All the numbers will be distinct, guys, right? They won't be repeating numbers. Okay, so let's try to submit it on Codeforces. And okay, here we have this answer. Here we should have x, right? Because x is the final answer that we are going to make, right guys? Let's try to submit it on Codeforces and new.cpp submit, right? See whether it works or not. Okay, so we are here, right? So we can see that it's an accepted code. So I hope you guys understood this. Thank you guys.